Hello. We made it. Good time of day. I think it can be morning or any other time. Welcome back to our corner where we study some fun stuff, including, but not limited to, definitely not limited to, things related to machine learning and natural language processing, and along the way we learn about fun stuff as well, but the fun stuff cannot be guaranteed. It just happens. Yeah, so let's start with a recap, I guess. Yesterday we went over some evaluation methods for language models in the Carnegie Mellon University lecture by our lecturer Graham Neubig. And then on the HuggingFace side, we finished chapter 3, the fine-tuning of pre-trained models, and if we do, we will start chapter 4. We could go either way. We could this is about sharing models and tokenizers on HuggingFace, so I think that would be pretty fun. I do want to start on the HuggingFace side again and go to Carnegie Mellon University maybe midway. We'll see. If the internet doesn't get cut off like it did yesterday, sorry about that. It just got cut off, and yeah. So we have interfaced with and had missions where one of the quizzes was like, go to the HuggingFace hub and do something about it. So what did I say? HuggingFace hub. Oh, I thought I said hub before face. I don't know. Okay. The HuggingFace hub, their main website, is a central platform that enables anyone to discover, use, and contribute to state-of-the-art models and datasets. It hosts a wide variety of models, with more than 10,000. Actually, it's way more than that. Way more than that now. I think it's in the hundreds of thousands and like even more. Publicly available. We can take a look, because I remember watching something online. See? And the guy was like, I can't put a number down because if I do, it will be updated so early. Now it's 600,000. It's been a while, I guess. Publicly available, right? We'll focus on the models in this chapter and take a look at datasets in chapter 5. Okay. The models in the hub are not limited to transformers or even NLP. NLP is just one part. There are models from FLAIR, which is the Facebook Lab of AI Research. Wait, no. FAIR is Facebook AI Research. What's FLAIR? I don't know. Cool. I don't know where the name comes from. And Allen NLP for NLP. Definitely there are models from OpenAI and Meta and Microsoft and Google for NLP. It's not just FLAIR and Allen NLP. Maybe it was just that then, but I don't believe that. There were always models from the big companies as well. Asteroid and Pianote, as in piano with note, okay, for speech, and Tim for vision, to name a few. But more, definitely more. Each of these models is hosted as a Git repository, which allows versioning and reproducibility. Sharing a model on the hub means opening it up to the community and making it accessible to anyone looking to easily use it. Okay. In turn, eliminating their need to train a model on their own and simplifying sharing and usage. Additionally, sharing a model on the hub automatically deploys a hosted inference API for that model. Isn't that pretty cool? Anyone in the community is free to test it out directly on the models page with custom inputs and appropriate widgets. The best part is that sharing and using any public model on the hub is completely free. Paid plans exist if you wish to share models privately. So this video below tells us how we can navigate the hub. Let's take a look. Here comes the whoosh.
In this video, we're going to go over the HuggingFace Model Hub navigation. This is the HuggingFace.co landing page. To access the Model Hub, click on the Models tab in the upper right corner. You should be facing this web interface, which can be split into several parts. On the left, you'll find categories, which you can use to tailor your model search. The first category is the tasks. Models on the hub may be used for a wide variety of tasks. These include natural language processing tasks, such as question answering or text classification, but it isn't only limited to NLP. Other tasks from other fields are also available, such as image classification for computer vision or automatic speech recognition for speech. The second category is the libraries. Models on the hub usually share one of three backbones: PyTorch, TensorFlow, or JAX. However, other backbones, such as Rust or Onyx, also exist. Finally, this tab can also be used to specify from which high-level framework the model comes. This includes transformers, but it isn't limited to it. The Model Hub is used to host a lot of different frameworks models, and we are actively looking to host other frameworks models. The third category is the Datasets tab. Selecting a dataset from this tab means filtering the models so that they were trained on that specific dataset. The fourth category is the Languages tab. Selecting a language from this tab means filtering the models so that they handle the language selected. Finally, the last category allows to choose the license with which the model is shared. On the right, you'll find the models available on the Model Hub. The models are ordered by downloads by default. When clicking on a model, you should be facing its model card.
So actually, a lot of stuff is rather changed. Not really, but sort of, because from the way I see it, we have a lot more information on this side, separated not only by, I was like, why didn't I see language? Because I care about searching by language, but apparently I was blind, because that is at the top now. There are far more tasks separated by category, and the libraries, which again I did not see. The data set, whoa, I thought you can just filter here, but you can actually filter on this side as well. I feel so unintelligent right now. Look, you can search by language. Again, I was like, how do I filter? Yes, you can sort by, now trending is a thing now, but filter by name. But apparently it was here the whole time. Whoa, what is that? Oh, this is cool. Ooh, carbon emissions. Okay, good to know. Now I feel less stupid, or not really, but let's see.
The model card contains information about the model, its description, intended use, limitations, and biases. It can also show code snippets on how to use the model, as well as any relevant information, training procedure, data processing, evaluation results, or copyrights. This information is crucial for the model to be used. The better crafted a model card is, the easier it will be for other users to leverage your model in their applications. On the right of the model card is the Inference API. This Inference API can be used to play with the model directly. Feel free to modify the text and click on Compute to see how would the model behave to your inputs. At the top of your screen lies the model tags. These include the model task as well as any other tag that is relevant to the categories we have just seen. The Files and Versions tab displays the architecture of the repository of that model. Here we can see all the files that define this model. You'll see all usual features of a Git repository, the branches available, the commit history, as well as the commit diff.
Okay.
3 different buttons are available at the top of the model card. The first one shows how to use the Inference API programmatically.
I didn't notice that.
The second one shows how to train this model in SageMaker. And the last one shows how to load that model within the appropriate library. For BERT, this is transformers.
I really did not see those. I feel 바보 같은 사람. Okay, so let's just choose something. Llama. Let's go. I did not see those. All the tags that were searchable are here. And then clone, add collection, report, train without code? Wow. What is that? What is that? Is auto train something that exists? And then for deploy, and then using the model, we have the pipeline, we have the if you want to separate the tokenizer model, or if you just want to use pipeline. Wow, this is really cool. Now I am less overwhelmed by the HuggingFace interface. It used to scare the hell out of me. Now I'm like, I understand what's going on, and that makes me feel nice. Yes, you need to have an account to manage repositories, so makes sense. I have an account, we're good. So using pre-trained models, meaning other people have trained them. Okay. The model hub makes selecting the appropriate model simple, so that using it in any downstream library can be done in a few lines of code. Let's take a look at how to actually use one of these models and how to contribute back to the community. Let's say we're looking for a French-based model that can perform mask filling. Okay, so you filtered by French, then you opened something, Cambert. That's it. All right. We select Camibert. I don't know. Bert checkpoint. Okay. To try it out. The identifier is, oh, you mean the title. All we need to start using it. As we've seen in previous chapters, we can instantiate it using pipeline. Why do I keep closing it? Alright. Let's go back to the hub. Filter by What do I filter by? Stop me from filtering by Korean. Okay, someone stop me. Let's go Arabic. We have text generation, we have ASR, we have text generation, we have sentence similarity, we have feature extraction, we have translation. Wait, there's something called the Google Mad Lad? Huh. MBART. What? Many to many. MMT? What is MMT? Multimodal translation? I doubt that. Multilingual. Ooh. So let's use the model. Let's copy this part. Can we change that? Oh, sorry. Okay, so I mean, I could have used this, but I want to use my own thing. Just paste the code here. And then we have something for translation. I think I had a text up there, did I not? An Arabic text from... I did not. It was a different place. Yep, different place. So... Oh. Yeah, I think it's really big. Ooh. Can I see the size? Because if it's like too big, then... where can I see the size? I'm gonna test. You should probably tell it what language it should. Ah, makes sense. Oh. I want to use this actually. Paste you. And Hindi to Arabic, Arabic to Hindi. Wait, Hindi to French, Arabic to English. Can we do the Hindi to English as well? Because I can't read French. That's really cool. Let's see how long that might take. In the meantime, score is delicious. Oh, is that a food? Is it food? Of course it is. Okay. This is so smart. As you can see, I mean the naming. As you can see, loading a model with a pipeline is extremely simple. The only thing you need to watch out, I mean, the multi translation thing was like, what do you want me to translate to and from? So, it made sense that. Oh, the printing happened once. All right. This is a very unfortunate sentence. Fun. I mean, it's just I don't like the fact that the Arabic. Anyway, I wanted to paste it. I mean, paste it, print it, print. Is that? Yep, decode. We have decode. So then this is sentence number 1. And then this is sentence number 2. Print. And go. Now I can see both, right? And you're loading again. You should have known that you were cached. So the only thing we need to watch out for is that the chosen checkpoint is suitable for the task. it's going to be used for. Okay. For example, oh, hi Jiho, good morning, or good night. We are doing some usage of models, just learning about the UI of HuggingFace. I did not see these buttons here, and when the video was like, you can just click here and it gives you the code of like how to call the model, or if you want to train it with SageMaker from Amazon, and I don't know, auto train is something I guess without code, like, or if you go back to the main UI, I never realized that you can filter by language like here, because I thought, yeah, I don't know why I didn't see it, or libraries, yeah, licenses, the tasks one, yeah, but I didn't see the buttons up here. So now I know. Okay. So this example above, I'm curious how this one is pronounced, because it's French. Let's read it. What? I can't hear it. Oh, because output is not outputting? But it was. No, it definitely output is outputting. Why can't I hear you?
Camembert.
Camembert?
Camembert.
Camembert, got it. Camembert? Something like that. Is the name of a model, which is fun. Is a fill mask pipeline, which is completely fine, but if we were to load this checkpoint in the text classification pipeline, the result would not make any sense because the head is not suitable for this task. It's not expecting to classify, it's expecting to fill. I guess the model can be delicious, yeah. It's just a really smart naming mechanism, because the bird part is already there, and it's the French version. Yeah. Now we have to all think of puns to name our models. Hey, Coffee. Good morning on my side. Yeah. Of course it was a pastry, or like food, because French. So we recommend using the task selector in HuggingFace interface to select appropriate checkpoints. Got it. Just looking at the list of tasks from that year and the list of tasks now, it's like grown, I don't know, 3 times. Feels that way. In English, I'd say it like camembert. Camembert. I think. Sort of vaguely like the French pronunciation, but without the r part at the end, yeah. Less authenticity. Camembert. That's, alright. That's fun. I don't know if I've seen that. Probably. I don't know. So, you can also instantiate the checkpoint using the model architecture directly. Okay. Yeah, we sort of did that here with our Arabic 2 thing. It's the same sentence but in Hindi and Arabic. Okay, and yes, we are calling model and tokenizer because we are using it to translate. Okay. However, we recommend using the auto ... class instead, as these are by design architecture agnostic, while the previous code sample limits users to checkpoints loadable from our Camembert. It has to be BERT because we're talking about BERT. Architecture using the auto star class, auto whatever class makes switching checkpoints simpler. Okay, so when using a pre-trained model, make sure to check how it was trained, on which data set, its limits, its biases. All of this information should be on the model card. Okay, so I had this. Oh, I closed it. I filtered by Arabic, and then I had this. Did I filter by anything else? Guess not, but this translation one, the model card, is saying it can directly translate between 50 languages, any pair. And then these are languages, and this is the citation info. Nice. So how one can share a pre-trained model. Okay, in the steps below, we'll take a look at the easiest way to share pre-trained models to the hub. You just push to hub, that's it. You log in and then you say push to hub. I think that's all that there is to it. There are tools and utilities available that make it simple to share and update models directly on the hub. Let's explore that below. Okay. Yep.
In this video, we're going to understand how to manage a model repository on the HuggingFace Model Hub. In order to handle a repository, you should first have a HuggingFace account. A link to create a new account is available in the description. Once you are logged in, you can create a new repository by clicking on the New Model option. You should be facing a similar model to the following.
So this is the manual way, and then there's the code way, which when you're training a model, you can just send it there. Name it. Oh my god. What's wrong with me? Nothing. I'm good. Okay.
In the owner input, you can put either your own namespace or any of your organization's namespaces. The model name is the model identifier that will then be used to identify your model on the chosen namespace. The final choice is between public and private. Public models are accessible by anyone. This is the recommended free option, as this makes your model easily accessible and shareable. The owners of your namespace are the only ones who can update and change your model. A more advanced option is the private option. In this case, only the owners of your namespace will have visibility over your model. Other users won't know it exists and will not be able to use it. Let's create a dummy model to play with.
Okay.
Once your model is created, comes the management of that model. 3 tabs are available to you. You're facing the first one, which is the model card page.
Right.
This is the page used to showcase your model to the world.
I just want to note that it says it was downloaded 11 times last month, meaning they either recorded this video multiple times or the guy just tested it before doing it, which good for him.
The world. We'll see how it can be completed in a bit. The second one is the Files and Versions tab. Your model itself is a Git repository. If you're unaware of what is a Git repository, you can think of it as a folder containing files. If you have never used Git before, we recommend looking at an introduction like the one provided in this video's description. The Git repository allows you to see the changes happening over time in this folder, hence the term versions. We'll see how to add files and versions in a bit. The final tab is the Settings tab, which allows you to manage your model's visibility and availability. Let's first start by adding files to the repository.
No, yeah, 1 minute ago. Then how come it's downloaded 11 times this month? The math isn't mathing. Maybe they deleted and added the file? But yeah, he just created it like right now for us.
Files can be added through the web interface thanks to the Add File button. The added files can be of any type.
Yeah, initial commit, yeah.
Python, JSON, text, you name it. Alongside your added file and its content, you should name your change or commit. Generally, adding files is simpler by using the HuggingFace Hub Python library or by using the command line. We'll showcase how to do this using the HuggingFace Hub Python library, and there is a link in the description to the previous version of this video showcasing how to do this using Git in the command line. First, make sure you're logged into your HuggingFace account, either through the command line.
Whoa, that's pretty.
Or in a Python runtime. The first approach we'll take a look at is using the upload file method. This offers an extremely simple API to upload files to the hub. The 3 required parameters are the current location of the file, the path of that file in the repository, and the ID of the repository to which you're pushing. There are a few additional parameters. The token parameter, if you would like to specify a different token than the one saved in your cache with your login. The repo type parameter, if you would like to push to a dataset or a space. We'll upload a file called readme.md to the repository using this method. We first start by saving a file with that name, which contains some information about the repository itself. Here, a title. Now that the file is saved, let's use the upload file method to upload it to the hub. If we switch to the web interface for a second and refresh the page, we'll see that the README is shown. The file upload was a success. Alongside this method exists a delete file method, so that you may manage your repository fully. We'll use it to delete the file we have just created. If we refresh the page once again, good, the file was indeed deleted. This approach, using only these 2 methods, is super simple. It doesn't need Git or GitLFS installed, but it does come with a limitation. The maximum file size one can upload is limited to 5 gigabytes. To overcome this limit, let's take a look at the second method, which is using the repository utility.
I thought he'll say to overcome this limit, you have to pay us, but I guess not.
This class is a wrapper over Git and GitLFS methods, which abstracts most of the complexity and offers a flexible API to manage your online repositories. Let's take a look at how it works. We first start by instantiating the repository utility. We provide the clone from parameter in order to clone the repository we just created. The repository is now cloned in the local folder. The repo object that we have just initialized offers quite a few methods which are useful for us. We're interested in pushing a model to the hub. I'll start by loading a model and tokenizer I trained a few hours ago. We'll now follow the traditional Git approach by first pulling latest changes using the git pull method. We just cloned the repository, so unless this is a super active repository, it's unlikely that new changes are available. But it's always a good idea to pull the latest changes before doing anything new. Now that we have pulled the repository, I'll save the model and tokenizer inside that folder. This includes the model weights, configuration file, and tokenizer files. Now that the model is saved, we'll continue with the traditional Git approach and push it to the remote repository. If we were using the command line, there are a few GitLFS specific commands we would have to invoke, but here, the HuggingFace Hub package takes care of all of that. We'll start by staging the files using the git add method. We'll then commit these changes using the git commit method and providing a helpful commit message. Finally, we'll push the changes to the remote using the git push method.
All right.
If we go back to the Files and Versions tab, we can now see the newly committed files. We can even play with the model in the Inference API. Unfortunately, the front page of our model is still very empty. Let's add a README Markdown file to
Whoa, you can already use it?
complete it a little bit. This read
Maybe the graph is from a hash of the files. Also, he just pushed and then it says hours ago. I'm guessing the recording is not aligned. I don't know. Like, it's not happening in the same day.
Unfortunately, the front page of our model is still very empty. Let's add a README Markdown file to complete it a little bit. This README is known as the model card, and it's arguably as important as the model and tokenizer files in a model repository. It is the central definition and documentation of your model, ensuring reusability by fellow community members and reproducibility of results, providing a platform on which other members may build their artifacts. We'll only add a title and a small description here for simplicity's sake, but we encourage you to add information relevant to how was the model trained, its intended use and limitations, as well as its identified potential biases, evaluation results, and code samples on how to use your model. Great work contributing a model to the Model Hub. This model can now be used in downstream libraries simply by specifying your model identifier.
Which is at the top, yep. Thank you, that was really useful. Okay, so this one is the API part, alright. We encourage all users that train models to contribute by sharing them with the community. Sharing, how many languages do you speak / learn? Human languages? Good question. Okay. So English is I always say a second language even though it's not, but I'm more comfortable with it. My second language is Arabic. But even yesterday someone was like, "You can't speak Arabic?" And I was like, my Arabic is horrible. But like Fusha is fine because it's like standard Arabic. But if you tell me like if you give me accented Arabic, like Egyptian, Lebanese, I will be lost. If you mean, because you said speak, then I'm guessing you mean human languages. My Korean is way better than my Arabic, which is, I don't think it's something to be proud of. Yeah, and then I speak my native language as well, and that's like 3 to 4-ish, something around that ballpark. Persian is rather easy to understand because it's really close to, it's just close. And I've watched a lot of movies and series growing up. But Turkish, 0. I'm just like thinking about the countries around my, where I live. Yeah. Like, the only thing is like good morning and stuff that I know in Turkish. Yeah. And then if we talk about English, I speak American English, British English, Australian English. I'm kidding. I'm just, saying that English can be used everywhere. That's why people become lazy when speaking. For non-human languages, computer languages or Klingon? For non-human languages, what is out there beside Klingon? Can confirm I am very languages. Yes, it's all the languages. Non-human languages are either computer languages or languages that were made for TV shows and stuff, which is, I love what's the belt language called from The Expanse? Because the Beltolata is like the people, I think. Yeah. So that's an artificial language, I'm guessing. Star Wars has an artificial language, and of course Klingon. Klingon, from Star Trek, right? I don't think I speak any artificial languages, but I do write down computer languages, and I started with C#, right? I mean, is SQL a language? Because if it is, then I speak it. Because that's like the first thing I started with, and then C# and Java and Python. Like Python I've done through like school and masters and all that. Java for work, C# for work, SQL for work. Yeah, I think Duhu, you can definitely say you are multilingual because you know a lot of artificial languages as well, and also for Riva. For some reason, I want to say Xavier. Thanks for the chat. I know you followed recently, but that was a first time chat, so thank you for that. Now everybody has to say how many languages they speak. Or no. Because, like, I just don't feel really comfortable saying I speak Arabic, even though I sort of can, just not good. English, poorly. Okay. Again, artificial languages are also languages. Yep. 3 ways to go about creating new model repositories. Push to hub. HuggingFace. Push to hub is an API. Okay. Using the HuggingFace Python library, using the web interface. Yes. Okay. Once you've created a repository, you can upload files via Git and Git LFS. We'll walk you through creating model repositories and uploading files to them in the following sections. All right. Oh, okay. Large file stars. Thank you. Okay. Oh wow, that section is surprisingly long because we are walking through it. Did not expect that because yeah, I thought we'd just see the 2 videos. All right. Video time. Go. Okay, is this video lower than the other one? Because the other one felt really loud, and I had to adjust the volume, and now I have to adjust the volume again.
The Push-to-Web API. Let's have a look at the Push-to-Web API. You will need to be logged in with your HuggingFace account, which you can do by executing this first cell or by typing HuggingFace-CLI login in a terminal.
Yes, okay. Don't know about the details, but I always imagine regular Git cares too much about checking change line by line for very large binaries. Yeah, I also don't know details, but isn't it pretty when you look at the changes? I like it. I like all the pluses and the minuses and the reds and the greens. But yeah. I don't know, maybe there's a way to just say don't check changes for such large files. Just like update, that's it. So there's the HuggingFace hub library with the notebook login method, and then it requests it used to request username and password, and now it just requests token. There's another way to log in where you just like enter your token here, because if you like want to run something multiple times or like just run it without needing to think about input, then it's possible, but this one is more interactive.
Just enter your username and password,
Mm-hmm.
then click Login. This will store an authentication token in the cache of the machine you're using. Now, let's launch a fine-tuning of a BERT model on the glue Collet dataset. We won't go over the fine-tuning code because you can find it in any Transformers tutorial or by looking at the videos linked below. What interests us here is how we can leverage the Model Hub during training. This is done.
It horrifies me when every line is changed, and it's because they oh yeah, the auto formatting. I mean, yeah, or like, yeah, no good comment. And in code review, I'm like, what did you even change in these? What? I didn't change. Yeah. Huh. Like I would normally press the auto format manually, like myself, because I like how it does it. But if it's 10,000 lines of code and nothing has changed, yeah, that is scary and just like annoying. Because like there are times you're like, okay, I remember this file being changed on that date with that change. I want to go back and just look at it. And then you get confused with the no code commits. Yeah. Life's not fair.
With the push-to-up equal true argument passed in your training arguments. This will automatically upload your model to the hub each time it is saved. So every epoch, in our case.
Oh, okay. So push to hub is an argument inside our training arguments method. All right.
This allows you to resume training from a different machine if the current one gets interrupted. The model will be uploaded in your namespace with the name of the output directory you picked by default. You can choose another name by passing it to the hub model ID argument. You can also push inside an organization you are a member of by passing a full repository name with the name of the organization / the model ID you want to pick.
Ah, makes sense.
With that done, we can just launch training and wait a little bit. I'll cut the waiting time from the video.
Thank you.
Note that the model is pushed asynchronously, meaning that the training continues while your model is uploaded to the hub. When your first commit is finished, you can go inspect your model on the hub by looking inside your namespace, and you'll find it at the very top. You can even start playing with its inference widget while it's continuing the training. The Collet dataset tasks the model with determining if a sentence is grammatically correct or not. So we pick an example of incorrect sentence to test it. Note that it will take a bit of time to load your model inside the inference API the first time you try to use it. We'll cut that time from the video. There is something wrong with the labels, but we'll fix it later in this video.
Yeah.
Once your training is finished,
Because it just got there, so 0 downloads. Yeah. Okay. Our Sherlock hats are on.
you should do one last push with the trainer.pushToHub method. This is for two reasons. First, this will make sure you're uploading the final version of your model, if you didn't already. For instance, if you used the save every end step strategy instead of every epoch. Second, this will draft a model card that will be the landing page of your model repo. Once the commit is done, let's go back on our model page and refresh. We can see the drafted model card, which includes information on which pre-trained model we fine-tuned, the final evaluation loss and metric, the training hyperparameter used, the intermediate training results, and the framework versions we used so that other people can easily reproduce our results. On top of all that information, the trainer also included some metadata that is interpreted by the HuggingFace website in the model card. You get the value of the metrics reported in a nice widget, as well as a link to a leaderboard with paper with code. C'est un answerable runs have also been pushed to this repo, and we can look at them directly from the Model Hub by clicking on the Training Metrics submenu. If you were not using the Trainer API to fine-tune your model, you can use the push-to-hub method on the model and tokenizer directly.
Wait, so if you just do the trainer API, it gives you the metrics itself?
We'll use this to fix our labels in the inference widget. The inference widget was using default names for labels because we did not indicate the correspondence between integers and label names. We can fix this in the configuration by setting the label to ID and AD to label fields to their proper values, then pushing the model config to the hub. Once this is done, we can check on the website and the model is now showing the proper label. Now that the model is
Oh, it was saying label 1 and label 0, but now it says acceptable and unacceptable.
hub, we can use it from anywhere as we would any other transformer model, with the from pretrain method or with the pipeline function.
This is really cool.
We just have to use the identifier from the hub, and we can see that the model configuration and weights as well as the tokenizer files are automatically downloaded. Try the push-to-hub API on your next training to easily share your model with the rest of the world.
It does feel clean and simple. So the simplest way to upload files to the hub is by leveraging the push to hub API. Before going any further, we'll need to generate an authentication code. Okay, so this is updated. The video wasn't. On HuggingFace, so that the HuggingFace API knows who we are and what namespace to write to. Make sure you are in the environment where you have transformers installed. If you are in a notebook, you can use the following function. Okay, I'll just continue with my previous notebook, and we are disconnected. But I think we'll be fine if I add a line saying sharing, I guess. That's where we are, which is a unit or chapter 4. And when you run this, it prompts you to get your token. You click it if you don't have a token. I think I'm gonna use this one. Oh, this is right. Refresh the token in order to copy its value. What does that mean? Sure. I didn't know you had to do that. Okay. So then we paste it, we log in, and that's it. We're logged in. Let's go back to the code. If we were in a terminal, we'd have to run this. In both cases, you should be prompted for your username and password. Not really, but okay. Which are the same ones you use to log into the hub. If you do not have a hub profile yet to create it, alright. Now we have been authenticated. Is that a word? We have authentication token stored in the cache folder. Let's create some repositories. Alright. If you have played around with the trainer API to train a model, the easiest way to upload it to the hub is to set the push to hub to true when we define the training arguments part. Alright. But are we gonna just we're going to make a dummy model? Okay. Alright. When we call the trainer.train, the trainer will upload the model each time it's saved. So every epoch in a repository in our namespace. That repository will be named like the output directory we picked. Oh, okay. Like this, okay. But it can also be renamed. To upload your model to an organization, we do this, give it a full name. Once the training is finished, we do trainer.push-to-hub to upload the last version of the model. It will also generate a model card with all the relevant metadata, reporting the hyperparameters used and the evaluation results. Here is an example of what it should look like. We have learning rate, we have batch size, train batch size, eval batch size, seed, distributed type, wow, number of devices. This is really useful. I don't think I've seen this I don't think I've seen this much detail elsewhere. Like, see, we have optimizer, learning rate scheduler, type, number of epochs. Maybe some people just remove this part. Okay. Yeah. So at a lower level, accessing the model hub can be done directly on models. Wait, how's that a lower level? That's the same level. Tokenizers and okay, all right, not pipeline. All right, configuration objects via their push-to-hub method. This method takes care of both the repository creation and pushing the model and tokenizer files directly to the repository. No manual handling is required, unlike with the API we'll see below. Okay. To get an idea of how it works, let's first initialize a model and a tokenizer. Let's do that. Let's get our French BERT model. Wait, it's not French. It wasn't French. Maybe it was just built by a French person, because because it was just a spell check thing. Okay. So we're free now to do whatever we want with this. Add tokens to the tokenizer, train the model, fine-tune it. Once we're happy with the results, weights and tokenizer, we can leverage the push-to-hub method directly on the object. Now that's a different level. That makes sense, because here we were doing on the training arguments and the trainer, but now we can just make changes to a model and then just update the model on the hub. Okay. Or just like update tokenizer on the hub. All right. If I do it, will anything explode? Brace yourselves. And that's cool. Nice. We have our dummy model. And it's tokenizer, right? So we have a new repository called dummy model. No explosions. When I was little and like we had a computer at home, like I guess neighbors or relatives were like, don't touch it too much. Maybe something like, in a way, it was like maybe something will explode. So that's why we say if something is new, like, yeah, let's expect explosions. Yeah. Explosions. Can I do explosions? Maybe I'll save some so that we have some explosions later. Create a new yes and add the model file and then the tokenizer so that it's there. I already did that, so let's just take a look. Look at all these pluses. Okay, and if you go to the model card, whoa, it gave me the whole whoa, that's so long, the whole template. And then we actually have, oh, it's not a spell check, it's mask filling. Okay. It should say capital. Wait, does it work? Because we're just using what's already there. And then I would say capital. I wouldn't say the city. Paris is the city of France. And then to update the mask, or I don't think I would write the word capital like that. France. Oh, sorry, mask. Capital? Yeah, okay. Max. Mask. Go. Oops. Oh, France is like all the way. Should I do a space? Is that my fault? No. Paris is the capital of the. I guess that works. The France. If I added the, just to make you happy. The world. Would you look at that? The future. The city. The people. Paris is the capital of the people. Yeah, Injong. I agree. Okay. If you belong to an organization, simply specify the organization arguments. Not gonna do that. I'm not from HuggingFace. If you wish to give it a token. Our token? Oh, a different token. Okay. Now we did that. We did. Look at the files and versions. We can also do that. We have a readme, we have tokens, config, safe tensors. Wait, it uses safe tensors by default. And then sentence piece, special token map, tokenizer config. And then this is like the biggest part. Large file storage. This one's not large, but that one's like the largest one. So now we did that. Oh, I didn't take BERT. I just took the one that we did. As you've seen, the push to hub method accepts several arguments, making it possible to upload specific repository or organization name, or to use a different API token. We recommend you take a look at the method specification available directly in the documentation to get an idea of what is possible. Alright. The push to hub method is backed by the HuggingFace Hub Python package, which offers a direct API to the HuggingFace Hub. Alright. It's integrated with the HuggingFace transformers and several other machine learning libraries like NLP. NLP, that's what it looks like. Although we focus on the Hugging Face transformers integration in this chapter, integrating it with your own code library is simple. Jump to the last section to see how to upload files in our newly created directory. I don't want to jump to the last section yet, but so we are here. Where are we? We are here. How much longer? Are we just halfway? I'm tired. I don't have the energy to use my voice. It's okay. Let me how long has it been? An hour and 20 minutes. Okay. Give me a second to drink some coffee so that I just get some energy back. Not a lot, just some. Okay. Still tired. I want to finish this part. All right. Using the Hugging Face Python library. Okay. I've used it for the login thing. Okay. Is a package which offers a set of tools for the model and dataset hub. Okay. It provides simple methods and classes for common tasks like getting information about repositories on the hub and managing them. It provides simple API that work on top of Git to manage the repository's content and to integrate the hub in your project and libraries. Okay. Similarly to using the push-to-hub API, this will require you to have our API token saved in cache. In order to do this, we need to log in and make sure to prepend command with exclamation point if it's in the Google Colab. All right. The Hugging Face package offers several methods and classes which are useful for a purpose. Firstly, there are a few methods to manage repository creation, deletion, and others. Creation, deletion, and others. Right with this one. So we have login for user management, logout. Who am I? Whoa, my brain just went to a really old movie. Where no, it's not. It's relatively old. It's Jack Chan, right? Where he's like, "Who am I?" Okay, come back. Repository creation and management. Create repo, delete repo, update repo, visibility. Some methods to retrieve/change information about the content. We have list models, list datasets, list metrics, list repository files, upload file, and delete file. And that's all a part of the Hugging Face hub package. Okay. Additionally, it offers the very powerful repository class to manage a local repository. We will explore these methods and that class in the next few sections to understand how to leverage them. The create repo method can be used to create a new repository on the hub. Okay, create repo, you give it a name, and it creates a repository. Good to know. This will create a dummy model in our namespace. We can specify the organization. Yeah, I know, you already said that like 2 minutes ago. I know I'm sleepy, but I'm not paying attention. I am paying attention. Okay. This will create the dummy model repository in the HuggingFace namespace, assuming you belong in that organization. I do not. Other arguments which may be useful are private, in order to specify if the repository should be visible from others or not. Token, to override the token, the stored token. Repo type, if you'd like to create a dataset or a space instead of a model. Okay. And then it can be dataset or space. For the space thing, I still don't know what's a HuggingFace space. Hope we'll learn that someday. Once the repository is created, we should add files to it. Jump to the next section. I don't want to jump, I'll just move. To see the 3 different ways that this can be handled. Okay. Using the web interface. I mean, we just explained those stuff, but fine, I'll read it. Okay, I'll do it. The web interface offers tools to manage repositories directly in the hub. Using the interface, you can easily create repositories, add files, even large ones, explore models, visualize differences, and much more. To create a new repository, you go here, and then you do this. You name it, you tell it if it should be public or not. For private, I don't know how many, like if there's a limit, because it's cool that they allow it at least. First, specify the owner of the repository. This can be either you or any organization you're affiliated with. If you choose an organization, the model will be featured on the organization's page, and every member will have the ability to contribute to the repository. Next, enter the model's name. This will also be the name of the repository. Finally. Okay. Model name and repository name. You can specify whether you want your model to be public or private. Private models are hidden from the public view. I promise not to tell you if you want to not to tell if I want to skip this. It seems like stuff you figure out without a tutorial. Yes. Like, I really appreciate how repetitive it is, because my brain needs something to be repetitive to understand. But it's alright. We will go through this. So after creating the model repository, we see a page like this. And the thing is, we already saw it from the video. That's why, like, it's, you either watch the video or you read this, but yes. This is where our model is hosted. To populate it, you can start with a README, and then README is marked down. Feel free to go wild with it. The third part of this chapter is dedicated to building a model card, so yeah, we'll do that there. This chapter, really? Okay. Oh, next page, yeah, okay. These are of prime importance. Someone got a new make and sounds awesome. Oh, that's so sweet. You are awesome. Someone is using their old beloved mic, and this sound is sounding okay, which is me. I found a really cool video on YouTube that makes sounds better, so I'll probably even use that, because now I have a noise gate thanks to Duhu's guidance, and I'm happy about that. But let's see what else I can do. This is like mandatory. We have to advertise the service in the course. Of course, yeah. We're using their environment. It makes sense. Thank you. So yeah, some of the thanks goes to Juhu. We have this thing in Islam. If you do something, like if you build a mosque, then every good deed that happens in this mosque, part of it, like not a part of it, like comes to you and also that person. So now, if my voice is good, part of the good deed goes to Juhu. Yeah. Okay. My brain was somewhere. Where was it? Beside that. Okay. Oh yeah, there. I'm actually going to allow myself to be distracted. This part, it says, these are of prime importance. And I still have not... I still have not finished reading... Well, I'm in book 2, so you can't really finish the series if you continue with the books. The Red Rising, and now I'm in Golden Sun, right? That's book 2. And they use the word prime to just mean like great. So like that's prime. So just seeing that distracted me too. Yeah. Okay. Live or replay? This is live. Hello. I don't do replays. I don't know. Like, does it matter? JSS 67200. Oh, 2006. Huh. That part? Okay. We are live. This is my radio sound. Like, it has to be low and close to the mic. Okay. Yes, importance, bringing value to the model. As I will say, just talking to the chat does wake me up. Alright. As they are where you tell others what it can do. Yes. Okay. So thanks, chat, for keeping me awake. And I should stay awake because it's morning. Unlike someone that should go to sleep. You know who you are. If you look at the Files and Versions tab, you'll see that there aren't many files there yet. Did I run it? I don't think I ran it. No, I'm not gonna... Okay. But yeah, just the README that is created and the Git attributes that keeps track of large files. Does this also take care of Git ignored? No, Git ignored is its own thing. Okay, got it. Welcome. Yes, welcome to the machine learning corner. But mostly NLP. We'll take a look at how to add some new files next. You can upload files. Okay. And then it handles, it's based on Git for regular files, Git LFS, which stands for large file storage. Yes, it does. All right. For larger files. And then let's go over 3 different ways of uploading files to the hub through Git command. Through the hub and through HuggingFace hub package, I guess, and then the Git command. Okay. The upload file approach, using the upload file, you can just upload files. Like I know people have used GitHub to have version control on like their books, nothing code related. So I bet you can do the same with HuggingFace, just like a storage place. Does not require Git and Git LFS to be installed on the system. It pushes files directly to the hub using HTTP post requests. Okay. A limitation of this approach is that it doesn't handle files that are larger than 5 gigabytes. If your file are larger than that, please follow other methods. So we just have upload file. That's it. You give it the path, path on the device, path in repo, and then the name that you want to name it. That's actually pretty cool. Thanks, trying to close my knowledge gap in NLP self-study. That's so cool. Since 2019, CS over 25 years. Hello, you are, I'd like to say in the right place, but I wouldn't say that I am a person who is, you know, like, I don't think you will learn from me, but if you learn through me, then great. What are you learning? Where's your interest right now? That's really cool. Not modest enough. Okay. Yeah, like, my idea is that we learn together, hopefully. And right now I'm just looking at how Hugging Face is being used. So if it's less NLP, it's not my fault. It's this course's fault, because the course is the NLP course by Hugging Face. ML since 2018. Your current interest is in generative AI. All right, let's see if Hugging Face has anything for that. We are in the upload file approach. Nope, we're past that. We're around that. Okay. I just want to go back to the Hugging Face learn page. Is there anything for not yet? No. I bet they'll add it though. Because, like, there are multiple ways. One is like usage, the other one is like you doing it yourself. For now, I guess Hugging Face would be mostly usage. Because, like, if you go to their models, I mean, you can definitely filter by text generation. There are 2 different tags. We have text generation, we have text to text generation. Don't know the difference. And then, yeah, llama is like at the top. That one's here. Yeah. Microsoft. So do take, I bet, I mean, yeah, I don't think you'll need my guidance, but yeah. Where were we? So you can upload your file to the hub from your device. This will upload a file called config.json, available at the okay, path to file to the root of the repository as config.json, to the dummy model repository. Other arguments which are useful are token, if we are using a different one, and repo type. Got it. So we have a repository class that manages local repositories in a Git-like manner. It abstracts most of pain points one may have with Git to provide all features that we require. Okay, I don't think I had any pain points. Using this class requires having Git and Git LFS installed so make sure that we have them. I mean, if I use them, I'll think about it. In order to start playing around with the repository we have just created, we can start by initializing it into a local folder by cloning. Okay, got it. So we take what's on GitHub this time. We clone it path to our dummy folder. This created folder in our working directory. This folder will only contain git attributes file, as that's the only file created when instantiating the repository through the create repo. We didn't really use it, but okay. We just used repository, and I'm guessing there are two different methods. From this point on, we may leverage several of the traditional Git methods: git pull, git add, commit, push, and tag as well. Okay, and others. You can look at documentation if you want. Yes, I co-stream on. Was there a question? On Twitch and YouTube, if you wonder why some messages do not show up. Yes, I do stream on both sites. I think someone was wondering, like, why are there messages when I can't see them? That's because they're from Twitch. And then there are messages from YouTube as well. Thank you for volunteering the information. And the Discord is linked around. Description of YouTube, around if Twitch. Thank you. There are ways. Yeah, I should probably do the socials thing. I don't think I've done it. Is it called a tag, or is it called something else? Okay. At present, we have a model and a tokenizer, and we'd like to push it to the hub. We have successfully cloned. I did not run any of the code. Yeah. Therefore, we can save file within that repository. Let's have our local clone set up by pulling latest changes, and then you just you load them. Save pre-trained, not from pre-trained. My eye saw from pre-trained. Okay. The path to dummy folder, useful information within a hidden plug for services. I learned it from HuggingFace course today. That is very very, yeah, useful information plus a hidden plug. Path to dummy folder now contains. One should learn as much as one can, even if it's strategy and not information itself. And I think we learned some strategy today. We follow the usual Git workflow by adding files to the staging area, committing them, and pushing them to the hub. Yep, git add, git commit, git push. Awesome. I didn't, but you did. Thank you. I am going to actually skip this because I will most likely just be using Notebook, but that's also possible. You can use the command line interface. So there are two approaches: Git-based repository. And someone told me that they won't snitch on me if I skip anything, so thank you. Okay, we are skipping and skipping. Alright. Yeah, we also have the UI. If one looks at the repository, I mean, I was just looking at it, honestly. I really was. You click it, you can see it, you can look at that. Yep, see, all of this is there. UI allows us to explore the model, file commit, and see different of each of the commits. Okay, so as much as like I'm actually interested in learning about the building a model card, I don't have the capacity to read right now. Like my reading, I'm done. I was reading a really fun book that I'm rereading yesterday. Like if I was reading that, I'd be fine. But this is too much information. Yes, I'm rereading Project Hail Mary by Andy Weir because I like the book. And like sometimes it surprises me. I'm like, huh, I read those parts? I don't remember anything. Yes. Here comes, let me know if I need to adjust the audio, because I might be louder than our lecture, because the Hugging Face videos are pretty loud. Let me check the...
Very similar to the neural network.
He's actually okay. Oh, I'm just too loud. Why am I so close to the mic? Okay. I'm okay. I think he's pretty okay. But if he goes away from the computer, then his voice might become lower, which is why I turn on closed captioning, just so that I understand what he's saying when he's further. So
I'd like to go into a few alternatives. These are very similar to the neural network classifiers and bag of words classifiers that I talked about before. So I'm going to go through them rather quickly because I think you should get the basic idea. But basically, the alternative is featureized models. So we calculate features of to count-based models as featureized models. So we
count-based, which are frequency, right? The n-gram stuff, models, language models, which are like super basic, but also can be used even now if you have really large models. That's what I remember from yesterday. And now we have featureized models, okay?
We calculate features of the context, and based on the features, calculate probabilities, optimize the feature weights using gradient descent, etc.
Etc.
And
okay.
so, for example, if we have...
Is it me, or do other people also... No, I doubt people would do that. For etc., because sometimes I forget. I found this joke like a bajillion years ago on the internet where it says etc. stands for end of thinking capacity, and each time I write etc, I'm like end of thinking capacity. I don't know if it's funny or not, but I find it funny.
Input giving A, we calculate features. So we might look up the word identity of the two previous words, look up the word identity of the word directly previous, add a bias, add them all together, get scores, and calculate probabilities, where each vector is the size of the output.
I think it's like old internet funny, because like, but I found it still funny, because sometimes people say etc, even though it's etc, but it's odd to say etc. So yeah, just to remember what the words are.
Vocabulary and feature weights are optimized using SGD. So this is basically a bag of words classifier, but it's a multi-class bag of words classifier over the next token. So it's very similar to our classification task before, except now instead of having two classes, we have 10.
I hope you don't mind me singling you out, but good night, Doohoo. Have a nice rest of... No, just like have nice sleep. If that bothers you, please let me know. I will stop teasing you, but also, yes, okay.
10,000 classes or 100,000 classes. Oh yeah, sorry, very quick aside. These were actually invented by Roni Rosenfeld, who's the head of the machine learning department at the machine learning department.
Who's machine learning department?
The head of the machine learning department at the machine learning department.
Their machine learning department? Are you writing this chat in your dream? Roni Rosenfield? Huh? How was it written? Rosenfield? Oh, it is from... That's cool. Ah, from our, he said. Ah,
By Roni Rosenfeld, who's the head of the machine learning department at the machine learning department. 27 years ago, I guess. So he has even
wow.
more experience large language modeling than I do.
I have recently had some problems sleeping and look at streams late at night. Streamers engage with me, made it harder. I know. I mean, do blame the streamers when you're the one chatting. But yeah. Engaging with chat, yeah, is infectious. So yeah, sucking at lurking. I suck at lurking because like I'm like I will be lurking, and then I'm like I want to say something. I don't think it's Stanford. No. Like if you're asking, it's Carnegie Mellon University, CMU. Yes. I can send you the link to this. It's actually it's in the description. The link to this playlist. Yeah. I put links in the description so that you can also go there. If you open more, it says link to HuggingFace, link to CMU course. I'll use end of thinking capacity for now and woohoo! Yeah, it's like a super old joke I saw somewhere. Like, I don't know. I won't say like 10 years ago, but maybe 15 years ago. Great, thank you. Do let me know if I share something and then it's not in the description, so I send it, and so that we're all confused together. Yes, because like each time I'm watching this lecture, 90% of the time I'm pretty confused.
Cool. So the one difference with a bag of words classifier is we have biases. And we have the probability vectors given the previous word, but instead of using a bag of words, this actually is using how likely is it given 2 words previous. So the feature design would be a little bit different, and that would give. It's
a context window, like an n-gram. No? Wait, no, I don't know. Okay, I'll shut up.
Give you a total score. As a reminder, last time we did a training algorithm where we calculated gradients of the loss function with respect to the parameters. And we can use the chain rule and backpropagation and updates to move in the direction that decreases the loss. So nothing extremely different from what we had for our bag of words classifier. Similarly, this solves some problems. So this didn't solve the problem of sharing strength among similar words. It did solve the problem of conditioning on context with intervening words, because now we can condition directly on doctor without having to combine doctor with Gertrude. And it doesn't necessarily.
I think perhaps, at least from what I've seen, Stanford is have better production values. Probably. I think right now our lecturer is recording this like on their own. Like he's the one who wants to publish it, and not the university. Like Stanford, they put it on their channels, but this is on the professor's YouTube channel and website, I think. Yeah, the slides and everything. So yeah.
Really handle long distance dependencies because we're still limited in our context with the model I just described. So sorry, back to neural networks is what I should say.
Camera was okay.
So if we have a feed forward.
I like that the camera is wide angle, because when he goes away, we can still see him.
Neural network language model, the way this could work is instead of looking up discrete features like we had in a bag of words model, we would look up dense embeddings. And so we concatenate together these dense embeddings. And based on the dense embeddings, we do some sort of intermediate layer transforms to extract features like we did for our neural network based classifier. We multiply this by weights, we have a bias and we calculate scores. And then we take a softmax to do classification.
All right.
So this can calculate combination features like we also used in our neural network-based classifiers. So this could give us a positive number, for example, if the previous word is a determiner and the second to previous word is a verb. So that would be like in giving, and then that would allow us to upweight or downweight particular examples. So this allows us to share strength in various places in our model, which was also, instrumental in making our neural network classifiers work for similar words and stuff. And so these would be word embeddings. So similar words get similar embeddings. Another really important thing is similar output words also get similar rows in the softmax matrix.
Cool.
And so here, if you remember from last class, this was a big matrix where the size of the matrix was the number of vocabulary items times the size of a word embedding. This is also a matrix where this is the number of vocabulary items times the size of a context embedding frame. And so these will also be similar because words that appear in similar contexts will also, want similar embeddings, so they get upweighted at the same time.
Okay, that's pretty cool. Speaking of lurking, I'll have to add this to my backlog of steel content to catch up on. Why? All right, thank you. No worries. No, you're not disrupting anything. Thank you for being here. Most likely, yeah, we'll see how long I can last. My brain says 10 more minutes, but let's see how much more. Thank you so much for being here. For the fun commentary, the informative commentary, and overall, the support. See you later.
And similar hidden states will have similar context. So ideally, like if you have giving a or delivering a or something like that, those would be similar contexts. So they would get similar purple embeddings out of the neural network. So one trick that's widely used in language model that further takes advantage of this is tying embeddings. So here, what this does is sharing parameters between this lookup matrix here.
Okay. I don't think I will be burning out because I do other stuff that I like taekwondo included. And I need to learn this because I'm working on something. So thank you. Appreciate the concern. Yeah. I might just do some random streams to lessen the burnout part, but we'll see. Bye. Please go. Don't wanna make you late. Yeah. But honestly, one of the reasons I wake up in the morning is so that I stream. It's something that I really want to do. It's not. I don't want to look like I'm doing this as if I'm being forced to do this. I want to do this.
And this matrix over here that we use for calculating the softmax. And the reason why this is useful is twofold. Number one, it gives you essentially more training data to learn these embeddings, because instead of learning the embeddings whenever a word is in the context, separately from learning the embeddings whenever a word is predicted, you learn the same embedding matrix whenever the word is in the context or whenever it's predicted. And so that makes it more accurate to learn these embeddings well. Another thing is the embedding matrix can actually be very large. So let's say we have a vocabulary of 10.
But for the whole thing, right?
100,000. And we have a word embedding size of 512 or something like that. That's 51 million parameters. And this doesn't sound like a lot of parameters at first, but it actually is a lot.
Did you say million? Why isn't 51 million parameters a lot? Is it because we're in the world of billions of parameters?
And this doesn't sound like a lot of parameters at first, but it actually is a lot to learn when these get updated relatively infrequently. Because these get updated relatively infrequently because they only are updated whenever that word or token actually appears in your training data. So this can be a good thing for parameter savings, parameter efficiency as well. So this solves most of the problems here, but it doesn't solve the problem of long distance dependencies because we're still limited by the overall length of the context that we're concatenating together here. Sure, we could make that longer, but that would make our model larger and bring various issues.
Okay.
And so what I'm going to talk about on Thursday is how we solve this problem of modeling long contexts.
We have 20 more minutes of class, don't we? 10, 20, 20. Okay.
So how do we build recurrent neural networks? How do we build convolutional networks? Or how do we build attention-based or transfer?
Convolutional stuff was like, I was shocked seeing Microsoft label Phi 3 as a small language model in their description. Because of the hyperparameter. Yeah, I guess it's growing. Goodbye, coffee. You not only suck at lurking, you also suck at leaving. Please leave. So, yeah. Convolutional neural networks were like the hot thing. I guess RNNs were pretty hot before transformers as well. So yeah. I do have the question of when are we doing the assignment? Because I really want to crack at it. Like, I really want to try, even if I fail. This was January 31st. According to their website, the deadline for the first assignment is 15th of February on their side. So I'm guessing he gives them, because okay, this is the assignment. Llama assignment, see? Yeah. And I could probably go through it later. But I want him to say, okay, start, because he should know when we're ready or not, right? As students.
Transformer models. And these are all options that are used. Transformers are kind of the main thing that people use.
You did a lot of study before these courses. Maybe in a future episode you could skip ahead to the assignments and look back at the stuff to fill in the blanks. Huh. Last message, you swear. I was like, I'm gonna be evil and ask something, but I'm not gonna do that. That's a really fun idea, to just like jump blind into a course. That is really fun. Like, just as content, it's like, I don't think, you're giving me ideas. Like, for LM and NLP stuff, I don't feel comfortable jumping in blind, but for other CS courses, I might. Like I'm thinking, how many assignments are there for CS50, and can I just look at them for fun? Because as long as I remember, I was like, I want to do CS50, but then I'm like, as fun as it is, I don't know, I've never gotten around to just going over them, but going through assignments might be fun. That was fun. That is fun. Practice makes perfect. It should. Sometimes. Yeah, no, it definitely does. I agree. Because actual practice, not just looking at lectures. That's why I want to try and crack at the assignments, even if I need a lot of help from chat. I might. We'll see. And maybe not Google chat the thing that I'm talking to, and then chat GPT, because that's pretty useful as well. Okay, let's see if he gives us the assignment today or not.
Nowadays, but there's a lot of versions of transformers that borrow ideas from recurrent and convolutional models.
I mean, yeah,
a lot of long.
they're built on top of each other in a way, right? I should stop interrupting him. Okay, go ahead, please.
Context models use ideas from recurrent networks, and a lot of, for example, speech models or things like, or image models use ideas from convolutional networks. So I think learning all of them is
Wasn't CNN like the thing for vision, as far as I remember?
sometimes a good idea in comparing them.
Cool. What is that?
Any questions?
What is that word? Desiderata? What does that mean?
About this part? I went through this kind of quickly because it's pretty similar to the classification stuff that we covered last time, but any things that people want to ask? Okay, so next I'm going to talk about a few other desiderata of language models.
Desiderata. Ooh.
So the next one is really, really important. It's a concept I want everybody to know. I actually taught this informally up until this class, but now I actually made slides for it starting this time.
Nice.
Which is calibration. So the idea of calibration is that the model, quote unquote, knows when it knows, or the fact that it is able to provide a good answer, provide a good confidence in its answer.
Okay.
And more formally, this can be specified as the feature that the model probability of the answer matches the actual probability of getting it right. And so what this means is...
Yeah. I was about to ask, what does that mean? And now he's like trying to explain it. So let's listen.
The probability of
probably
the answer, is correct, given the fact that the model probability is equal to P, So I know this is a little bit hard to parse. It always took me like a few seconds to parse before I like when I looked at it. But basically, if the model
same as essential. Thank you. You gave me the other essential models like that. Thank you. I was gonna Google it later to not disturb the flow, but I really appreciate you doing it for me, or just giving me the answer. The word just reminded me of the word diaspora for some reason. It looked that way.
Says the probability of it being correct is 0.7, then the probability that the answer is correct is actually 0.7. So
we're good.
You know, if it says the probability is 0.7 100 times, then it will be right 70 times. And so the way we formalize this is by this, it was proposed by the seminal paper by Glow et al. In 2017. And unfortunately, this data itself is hard to collect because the model probability is always different, right? And so if the model probability is like, if the model probability was actually 0.7, that'd be nice, but actually it's 0.7932685. And you never get another example where the probability is exactly the same. So what we do instead is we divide the model probabilities into buckets.
Hello. How's the learning going? Your Checkum is checking on us. I was wondering, is your avatar created with PingTuber? Nope. To answer that question, I have a long answer. I'm using an app What does YW mean? Ah, you're welcome. Sorry. Took me a second. There is this app that I just, the name put in the chat. It's a phone app where you can just decorate and build, like actually, you know, like you can choose the face shape, the eye, everything, the nose, the mouth, of an avatar. And like I'm using my phone with a green background, chroma keyed out on OBS. I'm using AnyDesk so that my phone's screen is on the computer and plugged into OBS. I keep saying I'll make a tutorial on what I'm doing because zero cost. So one day. It does the tracking for you, which is pretty fun, isn't it? No hand though. You are welcome. I don't know what you're thanking me for, I guess, for the name. But like I can't do like I can make it do poses with the hand and all. See, like right now I'm thinking. I like the pose where it looks like I'm saying hello or goodbye, which is this pose. I do it a lot. Yes. And then I go back to neutral. So I like there are thousands of poses to go through if you have the energy to use them. Yeah. And then there are like video versions. The other day I was like thinking of making emotes and I was like testing this laugh out and it's it's really creepy. Look. Yeah. Anyway. Yep. You're welcome. So yeah. Yeah, no, I was trying to recreate this, but I failed. Also, I don't want my characters to look that odd. Like with the whole face up and yeah, that was weird. Again, there are like so many different things. There's one where she's drinking coffee. Yeah. Satisfactorily accurate. It was. And now I'm drinking coffee. There's one where it looks like I'm in front of a computer and I tried to implement it, but I don't think I don't know, like I don't think it works well with our setting. I think I'd rather just look like I'm standing, because then I don't know. Yeah, it's more. Yep. Oh, changed my position. Oh, by the way, I can make myself super small if I want to. Yeah, a lot of room for changes and stuff. And obviously the outfits outfits are all from the app. You get some money token, whatever, inside when you watch ads, and you just buy outfits. That's it. And the fact that they have hijabi versions of stuff, that made me really happy. Yep.
You say the model probability is between 0 and 0.1. You say the model probability is between 0.1 and 0.2, 0.2 and 0.3. So we create buckets like this, like these. And then we look at the model confidence, the average model confidence within that bucket.
What's the difference between these two? They're different models? 1998 versus 2016, and the 2016 one is like not confident at all? Is that what accuracy? This is very cool. Thank you. I do think it's very cool. Again, the app, you just sign up and use it. It's like for other purposes. It has built-in games as well, if you want to waste time. I sometimes do. There was event with a game from the anime Titans, something. God, why did I forget? You know what I mean. And I played that and it was pretty fun.
Between 0.1 and 0. Between 0 and 0.1, the model confidence on average is 0.055 or something like that. So that would be this conf here. And then the accuracy is how often did it actually get it correct. And this can be plotted in this thing called a reliability diagram.
Mm-hmm.
And the reliability diagram basically, the outputs here. So this is the model. Yeah, I think the red is the model expected probability, and then the blue is the actual probability.
Mm.
And then the difference between the expected and the actual probability is kind of like the penalty there. It's how poorly calibrated the model.
Expected versus
And
actual,
one really
right?
important thing to know is that calibration and accuracy are not necessarily, they don't go hand in hand. They do to some extent, but they don't necessarily go hand in hand.
Mhm.
And the example on the left is a bad model, but a well-calibrated. So its accuracy is, its error is 44.9%, but it's well-calibrated, as you can see. Like when it says it knows the answer, it knows the answer. When it doesn't know the answer, it doesn't. This model, on the other hand, has better error, and but worse calibration. So the reason why is the model is very, very confident all the time. And usually what happens is models that overfit to the data, especially when you do early stopping on something like accuracy, when you stop training on something like accuracy, will become very overconfident and give confidence estimates that are incorrect like this.
Okay.
So this is important to know. And the reason why it's important to know is actually because, you know, models are very good at making up things that aren't actually correct nowadays. But if you have a really well-calibrated model, you could at least say with what confidence you have this working.
Fair. Okay, makes sense. I think the main issue is with the data. If you don't know what the data should be, then you don't know, right?
How do you calculate the probability of an answer? So, yeah, sorry. Yes. Yeah, please go ahead.
You should repeat the student question because it's really low.
Usually this would be for a generated output because you want to know the probability that the generated output is correct. Yeah. Right. Yep.
Mm-hmm. Can't hear anything. Let's see if he repeats it or not. Like I sometimes focus too much and my eyebrows become.
So perfect question.
Perfect question. Probably same question as this. Yeah, my eyebrows become like too and then I hurt my. I don't know. You know, like when you focus too much.
So how do we calculate the answer probability, or how do we calculate the confidence in an answer?
Mm-hmm.
We're actually going to go into more detail about this
Later
in a later class. But the first thing is probability
running cost loss function. Let's see.
Of the answer, and this is easy when there's a single answer. Like if there's only one correct answer and you want your model to be solving math problems and you want it to return only the answer and nothing else, if it returns anything else, like
it's wrong,
then you can just use the probability of the answer. But what if there are multiple acceptable answers? And maybe a perfect example of that is like, where is CMU located? Or where,
like the masked models where you can have multiple answers, and yeah, like spell checking even. Sometimes there are multiple answers.
where are we right now? if the answer is where are we right now?
Earth,
Could be Pittsburgh, could be CMU,
the Milky Way
could
galaxy.
be Carnegie Mellon. Could be other
Solar
things like this,
system.
right? And so another way that you can calculate the confidence is calculating the probability of the answer plus you know, paraphrases of the answer or other things like this. And so then you would just sum the probability over all the quote like acceptable answers. Another thing that you can do is sample multiple outputs and count the number of times you get a particular answer. This doesn't solve the problem of paraphrases existing, but it does solve the problem of it does solve two problems. Sometimes there are language models where you can't get probabilities out of them. This is not so much of a problem anymore with the GPT models because they're reintroducing the ability to get probabilities, but there are some models where you can just sample from them and you can't get probabilities out. But also more importantly, sometimes when you're using things like chain of thought reasoning, which I'll talk about in more detail, but basically it's like, please solve this math problem and explain your solution. And then if it will do that, it will generate you know, a really long explanation of how it got to the solution, and then it will give you the answer at the very end. And so then you can't calculate the probability of the actual like answer itself because there's this long reasoning chain in between, and you have like all of these other all of that other text there. But what you can do is you can sample those reasoning chains 100 times and then see how many times you got a particular answer, and that's actually a pretty reasonable way of getting a probability out.
Okay.
This is my favorite one. I love how we can do this now. It's just absolutely ridiculous, but you could ask the model how confident it is. And it sometimes gives you a reasonable answer. There's a really nice comparison of different methods in this paper, which is
the answer to the question at the top is less practical and more like methods that are used, right?
on the website. And basically, long story short, the conclusion from this paper is the sampling multiple outputs one is the best way to do it if you can't directly calculate probabilities. Another thing that I'd like people to pay very close attention to is in the generation class, we're going to be talking about minimum Bayes risk, which is a criterion for.
So we'll have a class about. Do you no? You can't see it because it's behind me. Let me change the scene. Yeah, generation algorithms after transformers and sequence modeling. So if you want to go just watch it yourself, please do that. As the link is below. Yeah. So, oh shoot, wrong scene. Okay.
Deciding how risky an output is, and it's actually a really good confidence metric as well, but I'm going to leave that till when we discuss it in more detail later. Any questions here?
Are lessons like this taught in your college? Sure. I mean, not really, not this advanced, but back in 2015, I don't know, something like that, we did have a class called AI, and I remember learning the word epoch in that class. We were using MATLAB. I remember nothing, but we were training stuff. I literally remember nothing. But I do remember going to a workshop, and not really, a Google group, developers group hangout, where a guy was talking about MNIST. It was like probably super new. And then when I got back to class, I told my teacher about it, and she was like, yep, there are a lot of stuff out there. The sad thing about that story is like she never encouraged me to, I mean, I don't know, I guess she didn't have the time. Like she didn't guide me to learn about other stuff. Cause like, I'm like, look, I went to developer hangout thing and I learned about MNIST, and she's like, yep, that exists. Like, dude, come on. Tell me to look for other stuff, like make me more interested. Anywho, I guess she might have, but she didn't give me anything in like to go and look up and learn about. I don't mean to blame her. She's cool. So yeah, I think there are like maybe if not just AI classes, AI majors even. Those are opening up. But because my master's in software engineering, I did not take this as a course when I did my master's. How many training epochs? Back then with MATLAB, like I don't know, 3, 5, something like that. But again, I don't know what we were training. I just remember learning the word epoch and thinking it's a cool word. Yeah, I mean, I did say I don't remember anything, but I do remember learning about back propagation and feed forward stuff. What else is there? Rosenblatt is the name of someone. Perceptron. Yeah, all of those stuff. That was 10 years ago, and maybe less. I don't know. I don't remember which, like if it was senior year or if it was before that. Okay.
So the other criterion, this is just yet another criterion.
By the way, I'm not a student right now. So not a student, not a teacher, none of that.
That we would like language models to be good at, its efficiency. And so basically the model is easy to run on limited hardware by some, metric of easy. And some metrics that we like to talk about are parameter count. So
about the time you entered. Yeah, but I wouldn't say like I entered into learning about ML then. I don't think I did. It was just something that was a class that we did. I got more interested during my master's. Yeah.
So often you will see, oh, this is the best model under 3 billion parameters, or this is the best model under 7 billion parameters, or we trained a model with 1 trillion parameters or something like that, The thing is, parameter count doesn't really mean that much from the point of view of like ease of using the model, unless you also think
way! You've attended CMU? Oh my god! That is so cool! It's like one of those schools that's like unattainable in my eye. And the fact that I can watch a lecture on YouTube is just, pinch myself worthy. I mean, I know there are lectures from MIT, Stanford, so all of that are pinch myself worthy. But also I'm not always someone that would go and watch lectures. I'd probably watch a video essay about something silly. But that's so cool that you went to grad school at CMU. Wow. It was CS, right? CS related.
other, desiderata. Like just to give one example, this is a parameter count. Let's say you have a parameter count of 7 billion. Is that 7 billion parameters at 32-bit precision, or is that 7 billion parameters at 4-bit precision? Will make a huge difference in your memory footprint, your speed, and things like that. So some of the things that are more direct with respect to efficiency are memory usage. And there's 2 varieties of memory usage. One is model only memory usage. So when you loaded the model into memory, how much space does it take? And also peak memory consumption when you have run the model over a sequence of a certain length, how much is it going to take? So that's another thing. Another thing is latency. And with respect to latency, this can be either how long does it take to start outputting the first token, and how long does it take to finish outputting a generation of a certain length. And the first will have.
You did an online from the West Coast campus from Pittsburgh area. I think they call this they used to call this distant learning, right? I'm actually, do they allow that? Like I don't think they allow that for international students. They're like, you have to be in the country because we may need you sometimes. I don't know. I have actually done a lot of research on distance learning because I was like, should I do it for a PhD? Yeah, that's, up in the air. But yeah, I know when I was searching, John Hopkins had a remote learning for like their practitioner, general practitioner, doctor stuff, remote. Maybe it was because of COVID times, I don't know. But and a lot of European universities allow that as well. Like I actually saw one from was it York University, something like that. They have a distance learning. Yeah, because if you call it online learning, people see it like in a different way, like because remote learning and online learning became prevalent during COVID. So yeah, because distance learning has been around for a while. Yeah, PhDs needs to be local because of the teaching. Yeah. The talking and the researching with your mentor honestly can be done multiple ways. Like I really don't mind if it was not in person, but the teaching thing, which is I think something that a lot of PhD programs have, that one can also be done remote. But yeah, I did apply to a local university quite recently, and I don't know where that goes. But I still also want to be, just, I don't know, learn from people outside. You've got a friend who's overseas for military who is looking for a master's program. There's plenty long distance. Yep. Embry-Riddle and University of Maryland global campuses are two that you've seen recently. Georgia Tech's one is like a really famous online masters. Masters are, I agree, there are plenty, but for PhD, it's like they are less open because they're like PhD, I guess needs the person to be on campus. Yeah, I will say that in a way, I have chickened out when I applied to the local one. But I'm still really interested in learning from people all over the world. Like, that's my motto, learn from everyone. Yeah, a lot of schools do it now, especially for masters and I guess bachelors. But PhD less so, but there are still programs out there. Like, it's not zero. Georgia Tech one is like really cool. OMSCS is the program's name. Online Masters course in something.
Have more to do with how long does it take to encode a sequence, which is usually faster than how long does it take to generate a sequence. So this will have to do with like encoding time. This will require encoding time, of course, but it will also require generation time. Also throughput. So, how many sentences can you process in a certain amount of time? So all of these are kind of desiderata that you would say about.
Interesting.
We're going to be talking about this more in the distillation and compression and generation algorithms classes, so I won't go into a whole lot of detail about this, but it's just another thing that we want to be thinking about in addition to complexity. But since I'm on the topic of efficiency, I would like to talk just a little bit about it in terms of especially.
I really should have gone by now. It's 2.5 hours that I'm here, but I want to finish this lecture before I go. Like, we have 6 minutes left. So sorry for keeping you guys. I'm not late, but I'd rather, 2.5 hours is way too long. My limit is 2 hours, but I did want to finish this lecture.
Things that will be useful for implementing your first assignment. And one thing that everybody should know about, if you've done any like deep learning with PyTorch or something like this, you already know about this probably, but I think it's worth mentioning.
We were doing it with HuggingFace. Gotta go to work? Nope. Or just limit myself. Yep, just limit myself. That's the reminder. I don't have to go to work because, long story short, I'm on a year leave. The limiting myself is limiting myself part, and I haven't had breakfast.
But basically, mini batching or batching is very useful. And the basic idea behind it is that on modern hardware, if you do many of the same operations at once, it's much faster than doing operations consecutively. And that's especially the case if you're programming in an extremely slow programming language like Python. I love.
Did you hear that? An extremely slow language like Python? I mean, call it slow, but not extremely slow. That's just mean.
Python, but it's slow. I mean, there's no argument about that.
Okay. Thank you. You're being so kind. Let me read your comment. No worries. You're an okay host/streamer. Glad I found you. Thank you. You're being really kind. I have a soft limit when I stop paying attention. Sticking with it is just useless. Good point. Even if it's an hour break where I think about it in the back of my mind. But it's not my main focus. I also do believe in breaks. For me, because I want to do this every day, it doesn't make sense for me to do it so long. And it's like my goal to do an hour of learning a day. And if I do more than that, then great job. If not, no worries. Yeah. Thank you for calling me a great host/streamer. I don't think I am, but I appreciate that you think so, and I will accept it.
And so what mini batching does is it combines together smaller operations into one big one. And the basic idea
yeah, we did mini batching when in fine-tuning a model on HuggingFace, where we did the batch padding collator thing of 8 batches of 8, and then we just padded them together. I think that's what we did. And then also the iterator, I think, worked with that as well.
For example, if we want to calculate our linear layer with a tanh nonlinearity after it, we will take several inputs, x1, x2, x3, concatenate them together, and do a matrix multiply instead of doing 3 vector matrix multiplies. And so what we do is we take a whole bunch of examples. We take like 64 examples or something like that, and we combine them together and calculate outputs. One thing to know is that if you're working with sentences, there's different ways you can calculate the size of your mini batches. Normally, nowadays, the thing that people do and the thing that I recommend is to calculate the size of your mini batches based on the number of tokens in the mini batch. It used to be that you would do it based on the number of sequences, but the problem is 50 sequences of length 100 is much more memory intensive than 50 sequences of length 5. And so you get these mini batches of vastly varying size, and that's both bad for memory overflows and bad for learning stability. So
are we saying mini batching is bad or good? Because TPUs can't handle them, but GPUs should, right?
I definitely recommend doing it based on
okay.
Another thing is GPUs versus CPUs. So CPUs, one way you can think of it is a CPU is kind of like a motorcycle. It's very fast at picking up and doing a bunch of things very quickly, accelerating into starting new tasks. A GPU is more like an airplane, which you wait forever in line in security, and then it takes a long time to get off the ground and start working. But once it does, it's extremely fast. And
I'm definitely in security right now working with the GPU. I still haven't been able to work with it.
So if we do a simple example of how long does it take to do a matrix multiply, I calculated this a really long time ago. It's probably horribly out of date now, but the same general principle stands, which is if we have the number of seconds that it takes to do a matrix multiply, doing one of size 16 is actually faster on CPU because the overhead it takes to get started is very low. But if you once you start getting up to size like 128 by 128 matrix multiplies, then doing it on GPU is faster, and then it's 100 times faster once you start getting up to very large matrices. So
Cool.
if you're dealing with very large networks, handling a GPU is good. And this is the speed up percentage. One thing I should mention is compute with respect to like doing the assignments for this class. If you have a relatively recent Mac, you're kind of in luck because actually the GPUs on the Mac are pretty fast and they're well integrated with PyTorch and other things like that. So decently sized models, maybe up to the size that you would need to run for assignment 1 or even assignment 2, might just run on your laptop computer. If you don't have a GPU that you have immediately accessible to you, we're going to recommend that you use Colab, where you can get a GPU for the first assignments, and then we'll have cloud credits that you can use otherwise. But GPU is usually like something that you can get on the cloud, or one that you have on your Mac, or one that you have on your gaming computer or something like that.
I don't have my local settings set up, but I don't know. Should I? Because it's M1, and I think it's supposed to be pretty good. Like, I know it's good, but I don't want to set it up locally. I don't know why.
There's a few speed tricks that you should know for efficient GPU operations. So one mistake that people make when creating models is they repeat operations over and over again. And you don't want to be doing this. So like, for example, this is multiplying a matrix by a constant multiple times. And if you're just using out-of-the-box PyTorch, this would be really bad because you'd be repeating the operation when it's not necessary.
Good point.
You can also reduce the number of operations that you need to use. So use matrix multiplies instead of matrix vector multiplies. And another thing is reducing CPU GPU data movement. And so when you do try to move memory, try to do it as early as possible and as few times as possible. And the reason why you want to move things early or start operations early is many GPU operations are asynchronous. So you can start the operation and it will run in the background while other things are processing. So it's a good idea to try to optimize. And you can also use your Python profiler or NVIDIA GPU profilers to try to optimize these things as well. Cool. That's all I have. We're right at time.
Okay.
Started in a moment. Since it's
no next lecture. We're good. We don't need to go to the next lecture. We are extremely good. Let's do a mini recap and yeah. So today, what did we do? Let me go back. We looked at sharing models and tokenizers on HuggingFace, creating your, repository, pushing to the hub and all that. So that was the first part, pretty fun. And then second part was I have not started building any actual projects. I've just gone with what's in each section. The section with fine-tuning a pre-trained model was pretty cool. Oh, don't say sorry, please. It's okay. No worries. There's a playlist of other streams. If you're interested, you can probably just skip some of the stuff because maybe it's I don't know. But the fine-tuning pre-trained model was really interesting. The using was pretty interesting, but we haven't done any actual project, I'd say. Yeah, and it's cool if you miss any days, because we have the VODs. If they're gone on Twitch, they're available on YouTube. Yeah, the recording of the streams. So for CMU, we are done with the lecture on language modeling, which was like overall, I think I understood it. I think like at least 50%. And now we're getting to sequence modeling, which will be for next time. So side question, yes. Did you have a link to the video that helped you with the audio? I should. It didn't help me with audio. It's something that I'm gonna apply because I'm using a different mic. But I will still share that video because it talks about noise gating, which is something that I'm actually using right now, and a whole lot more interesting ways to help with audio. So I'm gonna share, copy, and paste, and give me a second. Does this work? Did I send you the right link? Let's check. Yes, that's loud. But yeah, it's really useful. I just watched it yesterday. I didn't do the did you help you? She told me about what noise gating is on OBS. And yes, it was on stream, but like she just told me what it is. Noise gating. Oh god, sorry, my mic just maxed out. Because the environment was really loud. Like even when I was not talking, you could hear a lot of other noises. She told me that I can cut off noise to be quiet when I'm not talking and to pick up when I'm talking. And this video also talks about it. But again, my mic, I'm actually using something that I bought like years and years ago. I think it's called Fifine, something like that, Fifine. It was super cheap for a first time thing, and I'm still using it. Let me see if I can find it. Because yeah, like a very like if you Google it, you might not even find the one that I'm. I thought you lost your old one. Yes. And then the thing is, I felt embarrassed asking about it, and then my sister encouraged me to ask about it, and then when I did, the person was like, oh my god, I forgot to tell you that I have it with me. And then I went and got it back. I wasn't exactly losing it, but that wasn't with me. Wait, why can't I find the version? I'm trying to look on the website, but my version is not there. Is it that old? Yeah. I have a. Do I not have a spine at all, or do I have a soft spine? Something about spines. Let me see if I can find what it is exactly. I have the Fifine or Fifine. I don't know. Fifine. K668. Again, cheap and pretty decent mic. So if I Fifine. Yep, that's no 2 6s, not 6 8. Just a really cute mic. This is it. See, very simple, nothing fancy, just a mic. And it's $20. I don't know how much I bought it for, but I'm sure it was more than $20. Because that was like 5 years ago or something. Yeah. I bought it on Amazon then. Okay. Alright, this time I really will go because it's been long. So thank you for joining me. I mostly stream every day, but I don't know if I'll either take a break on Tuesday or just do a random stream. I'm feeling the random stream. We'll see. Thank you. Sounds good. Sounds great. Oh, I really don't mind. Don't apologize for asking questions, because it's cool to learn from each other. I like answering questions about the streaming setup, so I really don't mind. Oh, you don't need to thank me. I'm just doing it for myself mostly. Yes, thank you for joining me. If you can join me next time, I'd love it. If not, no worries. Time is precious, and you could just watch the video later, or even not that. You can just do the courses yourself, really. And if you're interested, there's a link to Discord if you'd like to say hi other times. Yeah, see you, I guess, next time. Do let me know if there's anything else you need. Otherwise, I'm going to end today's stream, and I normally do a countdown. So I'll do the countdown from 5. Yeah, let me know if... Yeah, that's all. Okay, I'm gonna end the stream. Thanks again for joining me, for your time and attention and your questions. Thank you. Have a good one as well. Ending in 5, 4, 3, 2, 1. Bye. Thanks. Good night and good morning.